Hello, this is Peter from Cyberstrak. With this video, I want to give you a short example of the workflow of the reverse engineering add-on to the Cyberstrak Modeling plugin. To access the commands, you need to have the add-on licensed. You can check it in the licensing commands that can be activated in the pull-down menu. There are currently 3 commands belonging to the reverse engineering add-on: mesh split, mesh area smooth, and create theory surfaces or reverse engineering workbench. Let's start with the mesh split command. When you start the command, you need to select a mesh. On this mesh, you can select further points. For this purpose, a mesh selection dialog appears. Around any selected point, a surrounding mesh area will be selected. The surrounding is defined by a normal angle difference that you can specify in the mesh selection dialog. You can increase, decrease the angle to influence the selection. At the end, you need to finish the selection loop by pressing Enter or right mouse button. Then you are back in the mesh split dialog. Pressing OK here stores the splitted meshes in Rhino. Let's continue to split the base mesh into more areas. Here we take the nearly planar area around the wheelhouse. Not all mesh faces are looking nicely here, so we just take the ones that are looking good enough to us. Pressing OK in the mesh split dialog again saves our changes to the meshes. Now we take another area in the back of our part. Let's now take over the area above the flat wheelhouse end. We use a 15-degree angle here. After selecting a couple of areas, we find out that we get all the areas that we don't want. But in the mesh selection dialog, we can also finish the add selection and press reduce. Now we can also define by an angle remove areas from the previous selection. We can finish this also by clicking either Enter or right mouse button. Then we are back in the split mesh dialog. And by the way, in the mesh split dialog, you will also find 2 more options what you can do with your selected mesh area. You can either just add the selected submesh to Rhino, or you can extract the edge of the mesh area as polyline. Here we will extract just the edge. Now I want to show you the mesh smooth command. Here you can select also a mesh area. In the dock bar, we can activate the zebra display on the selected mesh area. And here we see that the smoothness of the mesh can be improved. Pressing Apply in the Smooth Mesh dialog starts the smoothing process. You see the result is looking much better. You have also the possibility to show the deviation from the smoothed to the original mesh by the embedded analysis function. Pressing OK saves the smooth mesh to Rhino. The last command I want to show you here is the most complex one in the add-on, the so-called reverse engineering workbench, or just create theory surfaces. Also here, like in all other mesh-based commands, you need to select the base mesh first. After that, you are again in the familiar mesh selection dialog, and like in the mesh split command, you can specify an area. In this case, we select an area where we want to create a surface on. Please note, we create the surface not exactly on a selected area. We will get a so-called theory surface, bigger than the submesh. The mesh area and the surface belonging to it is stored in the reverse engineering workbench as in one area. The deviation here is just 0.25. The ruler from the docbar shows you the dimension of the part, so the deviation is already quite good. Internally, the algorithm tried to automatically find 4 corner points as basis for the theory surface creation. You may move the corners on the mesh boundary to find a potentially better surface. Now we repeat the same procedure in the next mesh area. In the docbar we can also influence how the selected mesh area is displayed. So we have options to showing vertices, net shading. We can also add transparency to the shading. Also here we can play with the corner points to find a better surface. Let's continue with the surface on the door. Interesting enough, you can also add mesh areas that do not belong geometrically together, but will still be used for the surface creation, like the door handle. When you leave the workbench with OK, the whole configuration is stored in Rhino. When you start the workbench again, you will find the complete setup back for further work. It is also stored in the Rhino file across sessions. So here we just activate it again and you see we get everything back. Next is surface creation on the roof. Here the deviation is much bigger, maybe because we should have used a higher surface degree and we also added mesh areas in the corners. But we can use this to show you another possible approach, improving the deviation manually using a special deviation analysis combined with CV modeling. The analysis function we will use is the shaded deviation. It creates a deviation map on the surface and compares it with the reference mesh. There's a color map going from blue negative direction to red positive deviation. With numerical min-max filters you can influence the color map. There is also a setting for the density of the color map on the surface. We increase the density here. Now we start the CV modeling command. With the extrapolate option in the CV modeling dialog, you can not only extrapolate, you can also shrink the surface on the edges. It looks as if it makes sense to increase the degree of the surface as well. Now we want to move CVs of the surface in normal direction. We add also the blend option to influence the CVs around the selected one. This will bring the surface closer to the mesh. The deviation may move then more into green color hopefully. In the middle of the surface we need to move the CVs now a little bit to the lower side. To shrink the surface more, we go again for the extrapolate option. Please note that you can shorten surface edges when you are selecting them close to the surface corner. With the tangent option, you can also move CVs tangentially on the surface. So finally you will get the surface pretty close to the mesh. That demo should have given you an impression of the functionality of the reverse engineering add-on to the Cyberstrak modeling plugin for Rhino. Thank you for watching.